My name's Cliff Morden. I'm from Intrinsyc Software, and I'm here to talk about technology considerations for high-performance wearable solutions. So the bad news is I don't have a demo today, and I guess the other bad news is there's going to be no spilling of beer or drinking it during this presentation. So Intrinsyc is a product development company. We do a lot of products for a range of ODMs and OEMs. And unfortunately, a lot of the neat stuff we do, we're under NDA and we can't talk about. But some of the technology that's being used today, particularly for wearable solutions, I'm going to have a look at particularly focused on phones and the phone technology and how it's applicable to wearable solutions for high-end solutions. And what I mean by high-end solutions, I mean things like Google glasses. A lot of industrial headsets are using it. We've got customers who are looking at eye tracking, scene. They have products that will track eyes and track scenes and overlay eyes and do some analysis, particularly in medical areas. So there's a range of applications that need high performance solutions, and most of these solutions are going to be derived from phone technology. What I'd like to start off with is looking at the challenges and how the phone technology can help some of those challenges. So the first thing is processing power. A lot of our high performance solutions need either high levels of processing power, high levels of graphics, connectivity, and a range of sensor support. And obviously the bad thing about that is the power management. Somebody earlier said that batteries don't follow Moore's law, and unfortunately these guys, the processing power is following Moore's law. The processor we're going to talk about is 50% higher than the previous version, and that's come out in less than a year. But the batteries are no longer are not meeting those requirements, and so it's incumbent on the designers of the chipsets and the solution sets, and we'll talk about that, to ensure that you don't get an extra 50% more power from a processor without consuming more battery life. You don't get more CPU cycles, more higher clock rates without consuming extra battery life. So the way around that is to be smart in how the silicon's architected and how the product's architected, and I'll talk a little bit about that. And finally, the last two bullets are about development tools and applications. We have a lot of customers that come in and look at the application space, and they quickly and unfortunately have to dive down into the basic plumbing of the device to make sure that the services and infrastructure, middleware, et cetera, are available to meet their needs before they can start looking at their applications. What I'm going to talk about today is some of the middleware and some of the services that are available that can relieve the application developers, so the application developers can just focus on what they need to develop and not get bogged down with the details of the platform. So what do I mean, and what technologies are available that may be applicable or is applicable to cell phone technology, to wearable solutions from cell phone technology? High-end systems, CPUs, these are complex devices. They have a lot of subsystems inside it. They have power management systems, they have CPUs, they have media processing, they have DSPs, and I'll talk a little bit about those, but these are complex systems, and they're designed for power and power management, and how those come together. There's also a range of facilities and support that come with these processors typically on the market. There's stereoscopic vision, there's camera and facial object recognition, there's sound, there's voice commands, there's noise cancellation, there's environmental sensors, there's motion sensors, there's high-end video displays, and there's touch-free gesture controls. All of these are very applicable to the wearable solutions environment. So I'd like to talk about the Snapdragon 800. The reason I've chose this is the Snapdragon is the leading edge. This particular processor has only just come on the market. It's not in a product yet. It'll be in product Q3, Q4. So it's a good representation of what's out there and what's available for use. And it's a good indication of where the industry is going. So the type of processor the Snapdragon 800 series supports is it's a quad-core processor running at 2.3 gigahertz. It's got an Adreno GPU, which it's a 50% improvement, which doesn't mean a lot to you guys over the previous version. Actually, the CPU is about 40-50% as well, which goes back to power management. The previous version of this processor was in the Samsung Galaxy series of phones. So you can imagine now this is going to be 50% better, 50% more graphics. It supports in silicon, not external. It supports in silicon, the Wi-Fi stack, the USB stack, the Bluetooth stack. It also supports ultra high definition, which is a 4K displays. It has it's enhanced sound, which is probably not as useful for wearable devices, but it does also on the multimedia side support gesture control. It has 55 meg input with dual processors for cameras. It supports up to 4 cameras. It has displays, and it supports all 3 constellations on GPS. So let's take a look at some of the applications and support middleware that's available on these things. And they all start off, our key area is OpenCV and FastCV. OpenCV is an open standard for programming for real-time vision and processing. FastCV is Qualcomm's version of that, and it's really been enhanced and optimized for the platform. So you get a bang for the performance, you get a bang for the power management. And why are we interested in this? Because it's the building block for a lot of other areas. It's a building block for text recognition, it's a building block for augmented reality, face detection, recognition, and gesture recognition. Other SDKs that are built on top of that are things like the camera SDK, which has face detection, smile detection. There's also audio SDKs. Fluence Pro is a active noise cancellation. The technology in these devices is tremendous. Noise cancellation is based on beam shaping. It's multiple microphones and beam shaping that's taking place inside your phone to reduce the noise cancellation and direct the sound. There's also Listen, which is a voice-activated mechanism. Again, it's power optimized. It puts the CPU to sleep. And when you command, it's got very low latency to wake up and issue the commands, and process the commands, sorry. There's also sensory gestures. There's location SDK for improved georeferencing and algorithms. There's FastCV, which we've talked about, and graphics. And graphics, the graphics SDK is really low-level graphics. We have some customers who need to get down to the very low-level graphics to process their applications. A typical example is augmented reality. So this is where we take a real-world view from a live camera. We take the object, which is the Cheerios box. Based on the Cheerios box, it would do a comparison of objects, either locally in the device database or in the cloud, identify what the objects are, and come back with, in this case, it's an animated GIF, but it could be a new application, it could be a product promotion. So this is all about augmented graphics, and the whole framework is available on the platform. All the application developer has to do is use the APIs and drive this. All the infrastructure for augmented reality, the image identification is all built in. So finally, I'd just like to cover what we talked about, and this is why I feel that the phone technology is very applicable to, as I say, wearable solutions. First of all, you're leveraging R&D from the major phone manufacturers, major silicon manufacturers. Qualcomm, for example, are the leading phone silicon supplier, and they spend a tremendous amount of money on R&D. You're getting the latest generation of CPUs. In this case, it's the ARM 15 class. You're getting dual and quad processors. These are PC level processing capabilities. But they're also, we also provide rich multimedia displays, dedicated processors for GPU and DSP. They're very leading edge in terms of power management. They have to be, as I said before, because the batteries capabilities are basically static. They have dedicated hardware and dynamic voltage and frequency scaling. I won't discuss that, but it's a mechanism for throttling back the processor to make sure you're just using enough power to do the processing you need. And it also has a number of thermal constraints to make sure that it has temperature gauges to make sure that thermally within your industrial design you won't overpower the limits. And finally, it's got rich developer support tools. We have Android and Linux support, OpenCV, and a range of optimized SDKs for immediate application development. Okay, that's it. Thanks.